So, countercurrent exchange is a mechanism that consists of two properties, which could be gas or liquids, which are flowing in opposite directions. Now, these two properties do not mix but are in close proximity in their movements. In animals such as Arctic fox, ducks, and deer, the countercurrent exchange mechanism is used for heat conservation. For example, Arctic fox live in cold environments that typically consist of snow. It has a countercurrent heat exchange and the circulation of its paws to maintain body temperature in its cold climates. The blood vessels are designed to allow the warm blood, which is traveling from the body, to flow towards its feet, while the cool, deoxygenated blood leaving its paws flows in close proximity towards the heart. Now, due to the proximity and the opposite flow directions, the heat from the warm, oxygenated blood, which is coming from the body, is able to warm up the cold blood, which is leaving the feet as it travels back up to the heart. So, this exchange of heat is able to allow the Arctic fox to maintain its body heat, and it prevents its paws from having frostbite. Now, in countercurrent exchange in fish serve a different purpose. The purpose in fish is to maximize the amount of oxygen in the blood. Now, within the gills are gill lamellae, and the lamella maintains the concentration gradient. So the blood that leaves the body and maneuvers to the gills is deoxygenated. The water that flows from the gills, that flows in the opposite directions, has high levels of oxygen. So the high oxygen concentration from the water diffuses to the lower concentration which is in the blood. So as the water and blood move in opposite directions, the water loses more oxygen and the blood gains more oxygen as they flow along the lamellae. So the diffusion between continues until the concentration of the oxygen are equal between the blood and the water. Now, another example of counter current exchange would be in desert animals. So kangaroo rats, for example, have this mechanism also, but for their purpose it is to decrease water loss. So water conservation is important due to the dry, hot desert, which is their environment. The kangaroo rat has a single nasal passage that is responsible for inhalation of dry, cool air and then the exhalation of hot, moist air. So as air is being inhaled, it absorbs heat and moisture from warm tissues as it passes across the nasal mucosa. Now, when the air is being exhaled, the warm, moist air passes over the nasal mucosa, releasing the heat and the water, condensing on the mucosa. So this water will be able to be available and accessible for the next inspiration or inhalation for the kangaroo rats. So this is how they help them conserve water in their environment. Countercurrent exchange is also used in the energy industry. One of the most common appliances that we use that we don't think about that countercurrent exchange is used in is in a refrigerator. So in a refrigerator, the fluid that is used is called a refrigerant. And in the process of cooling your refrigerator, the refrigerant is used in keeping the freezer as well as the refrigerator cool by constantly transforming into a liquid into a gas. So how this works is it starts in the refrigerator, the refrigerant, as a hot gas. So this gas is moved by the compressor, which creates positive pressure by constricting the gas, allowing it to move through the coils, which is on the back side of the refrigerator. So then the gas cools while traveling through these coils. So either traveling and cooling, it transforms the gas into a liquid. So returning back into the refrigerant travels through a capillary and through evaporator coils, which, like I said, is located inside the refrigerator. So the refrigerant entering the refrigerator is cool. Therefore, it begins to expand and absorb the heat that is inside of the refrigerator. So as the heat is being extracted by the refrigerant, it cools the refrigerator. And then it starts this process all over again.